nowadays. We have somewhere between, say, 50 and 100 contributors in any given year. My background is intersects with, I think, many of yours in unusual ways. So I received my PhD from Clark University as a geographer. I went on to do my postdoctoral research at the National Center for Atmospheric Research, where I was involved as an author in IPCC's AR5 report. Um, I then moved into working much more in the international development community because I lost all hope that we could do anything to meaningfully mediate climate change. And since then, I have really gone deep down the satellite imagery analysis rabbit holes. I now am the chair of our data science department here at William and Mary. Um, GeoBoundaries itself was born out of a recognition that huge swaths of academic literature across multiple disciplines were organized around administrative boundaries. I saw this in my work with the Global Environment Facility all the time, where policy decisions and choices would be predicated upon, we would allocate funds to a district. And yet we didn't have good geospatial information on what those districts were. Many different sources fundamentally disagreed with one another about what those districts were. And so we started back in about 2016, 2015, trying to dig in and answer why. Why does everyone disagree on boundaries? And what might we be able to do to help to mediate some of those concerns? And we've been on that journey ever since. And I will emphasize it's a journey. And so that's one of the reasons why I'm talking to you all today, is to learn more about how you could use this type of data, the types of things that aren't in the data today that could be improved on, and related types of topics. So from a very high level first, just what is GeoBoundaries? So all of you can look at GeoBoundaries right now. It's online at geoboundaries.org. We've been around for, let's call it 8 years now. And what we do is we collect boundaries of hundreds of thousands of states, counties, and other districts around the world. So we focus predominantly on kind of what we call ADM 1 and 2. So in the United States, that would be the equivalent of our states and our counties. But that, of course, varies around the world. We do, for many countries, also provide ADM 3, and in some cases, all the way down to the 5th level of administrative unit. France, India, and Ireland, I believe, being the 3 that have those. We've, from day one, focused on ensuring that these are in standardized, machine-readable files. We have an API that can serve this data. And we have around today 60 terabytes of data that we're serving to around, it's actually about 1,000 users a week right now. We have really good community. So we have a community created R and Python package that allows people to pull our data directly in for analysis, in addition to, I think, a pretty easy to use API that you can plug into most other things. So just to give you an example of what these things look like, so this is kind of just an ADM1, and you can see what we effectively are doing is we are identifying the vertices along each one of these boundaries. Importantly, really importantly for geoboundaries, we only pull from sources that are compatible with the CC BY license. So probably all of you in the room are familiar with Google Maps or OpenStreetMaps or other similar kind of aggregation services. In both of those cases, unfortunately, the licensure that comes with them precludes many, if not most, types of academic usage. And that's unfortunately even true for OpenStreetMap and the ODBL license that they release under. So we may not always have the absolute best source available, full stop, in GeoBoundaries, but we will have the most useful source available in terms of licensure. Just to give you an example here, if you use a OSM-based data product and you attempt to publish in a journal like PLOS One, you can't, because the license is incompatible with their license, whereas CC BY is openly compatible with nearly any journal article or journal publisher. So in terms of granularity, here's an example of ADM2. So you can see we go from, relatively coarse distinctions to much finer distinctions. And then even here's, it's a little silly, but down to the level of ADM3. And so these zonations across different countries are used for all sorts of critical things. These are used for census information. These are used for collecting information for different types of censuses for both humans and animals. They're used for policy decisions. In my field, things like the Social Vulnerability Index or climate-related indices are frequently calculated on the basis of administrative boundaries. We also see a huge amount of uptake in the medical fields as well when people are looking at disease kind of spread and distributions. Much of that information, when it's collected by local governments, is collected at these administrative zoned levels. And you might get a name associated with a number, but you don't actually get a geometry. And so that's where we come in and can kind of bridge that gap. Now, we are not the only group that has sought to collect administrative boundaries, and there are trade-offs between different data products that are out there and available today. So, geoBoundaries, as I noted, we are really laser focused on providing up-to-date, really open licensed information. But that contrasts to others. So GADM was the first kind of major purveyor of what I will call somewhat open data. So GADM is an amazing resource, gaddm.org, of administrative boundaries. It unfortunately doesn't have full governance information. So we don't know for any individual boundary, you don't know in GADM where that boundary actually came from. And so it's very, very difficult to use GADM for a lot of reasons because of that. GADM is also unfortunately very irregularly updated, and the update process is fairly opaque, whereas ours is fully managed on GitHub, and anyone in the community can kind of provide new boundaries. But GADM for the longest time, I mean, I owe much of my own dissertation research to GADM. It was the only show in town, and they're still available and still do updates sporadically. UN SALB, which I am praying survives the coming apocalypse at the United Nations, is another just amazing resource to be aware of here. The United Nations, they actually work directly with local governments to get formally authoritative boundaries from those government sources, where the government of Malawi signs off and says, yes, these are our ADM2s. So really, truly authoritative, whereas ours might come from atlases, right, or from NGOs on the ground. UN SALB releases these under a few different licenses depending on the country that's providing it. So sometimes it's usable and sometimes it's not. The biggest limitation of UN SALB, and we work closely with them on this, it's that it takes a really long time for any government to agree to publicly state what their boundaries are. There's a lot of disincentives for them to do so, and so their coverage is fairly sporadic as such. We, with geoBoundaries, actually fill in a lot of the United Nations gaps because of this. So we work with UNICEF and the UN OCHA portal to basically, we provision around 120 or so of their boundaries, and then they have 60 that they provision themselves. In addition to that, there's a lot of ad hoc portals that you can get information from. I think UN OCHA has the best one. You've probably may have heard of HDX. Again, on HDX, geoBoundaries is actually fairly prominent. We do provide a lot of boundaries there. But you can, in those portals, you can frequently get the data on administrative units that are provided directly by people that are on the ground that day. Now, licensure might not be that important to them, but if you need something that is as accurate as possible, you're not going to be using it for publishing. There's a lot of good opportunities from a lot of different kind of NGO sources. Again, God willing, much of that survives. And then I did mention before OpenStreetMap, right? OpenStreetMap has some tremendous opportunities. The ODBL license that it is released under does inhibit uptake in some communities that I care a lot about, especially the publication community. But it is open for many, many, many different purposes, and many people do use it. There is a lot of bias there. I mean, as with any crowdsourced product, you see much higher quality and regularity of update in more densely populated areas, but it's still, I mean, a very high quality source. One other note as well, many of you may have been familiar with the United Nations FAO, what was called GAL data set. One thing we found through this, so when we set out to create geoBoundaries, one of the things we were trying to answer is why isn't this simply available? You would think everyone who went to kindergarten, there was a map on the wall and it had the administrative boundaries of the world. So it was a little shocking to us that this data wasn't simply available and open. And so we started to kind of probe into this question, and one way we got at this was looking at how the United Nations has handled this. And so for a little while, the United Nations did release such a data set up until about 2012, 2013. It was called GAL. It might have been to 2016. And unfortunately, due to, as I understand it, internal kind of political struggles and debates, that was discontinued. And what we learned from that process is that this is actually something that we think it's really important for academia to provision. Within academia, when we make decisions regarding what color Crimea is on a map, that has a different connotation than when it is done by the United Nations. And the United Nations is actually really ill-suited to make those types of decisions because it can cause discontinuations of products that are trying to do this type of thing. Just to give you an idea, though, of how important it is for our community to kind of come to the table and talk about this. So what we did as a part of one of my PhD students' dissertations is for every major data set out there, the ones that I just discussed and a few others, we downloaded their ADM2s, so counties in the United States, districts in other places frequently, and we just compared them. We compared to say, okay, across all these different data sets, how much agreement geographically is there with regard to where these ADM2s are? And what we found is that there's not much. Depending on if you download your geographic data from geoBoundaries or GATM or the UN, wherever you want, you're running the risk of getting, sometimes 50% or less agreement in what those zones are. And that can have tremendous downstream implications for a lot of different reasons. One is statistical analysis. If you're trying to figure out if there are correlations between X and Y and you have ADM level data and where those ADMs are or how big they are change dramatically, that can really change the outcomes of your results. We also saw downstream impacts in policy where, two different collaborating aid agencies are trying to work together in a region, but they're both using different maps. The most extreme example of this, we received some funding from the Gates Foundation where they were doing vaccinations for polio in Africa. And they were pouring resources into a relatively small area, and they could not get to 100% vaccination rates, no matter what they did. And so we started probing a little deeper, and it turned out there were two different maps they were using. And across these two different maps for two different communities, there was a sliver of an area that simply no one was actually engaging with. And this was purely because they happened to download maps of ADM3, I think in that case, from two different places. And so this disagreement can have real on the ground impacts, and something that we're working hard to try to resolve. I won't go too much into this, but this is an example of kind of a real world disagreement at an ADM1 level to give you an idea of how these different mismatches can occur. There's lots of reasons why mismatches can occur. Sometimes it's as simple as the relative resolution of the map. So I believe, if I had to guess looking at this picture, the coarse one in red is from Natural Earth, and the black one is more than likely from geoBoundaries. And Natural Earth is another wonderful source for administrative boundary information, but it's designed for visualization purposes only. And if a user doesn't know that, then you can end up with big mismatches. Other mismatches, though, are much more difficult to identify. Administrative zones are not static. They change over time. And so sometimes people simply have outdated maps. Sometimes there is conflict and people disagree over what these boundaries are. And so depending on the source you retrieve a boundary from, the boundaries can be drawn differently. So we're really trying to juggle all of these things and be as transparent as possible in the geoBoundaries product. This is geoBoundaries as it stands today. So in blue, you see where we have authoritative information where we've actually either worked directly with countries or those countries have open portals. In orange, you see where we've worked directly with United Nations counterparts to collect information. In green is where we're still reliant on OpenStreetMap, and that does come with some licensure restrictions. It's a little outdated. We're farther along than this map shows. And then other is generally cases where we have worked with either partners on the ground or we have found atlases and hand digitized atlases to then get information on where the actual boundaries are. On the back end, I've been led to believe that many of you are of the technical persuasion, and so I wanted to show a little bit of what our actual stack is to get this done. So one really interesting thing about geoBoundaries is we have built this to be completely transparent all the way through our entire pipeline. And this is really important to us because some of the decisions we make do have pretty substantial political ramifications. So as such, every single boundary that is submitted to geoBoundaries is in the form of a GitHub pull request. We have some automated tools to make that easier. We have a series of automated checks that happen against those GitHub boundaries to make sure that they're accurate, they have accurate metadata, they don't have self-intersections and all that kind of stuff. Once they pass those kind of automated tests, we then assign this to one of our community members, and generally we assign it to two community members, but at least one. That community member's job is to basically triangulate to see if the boundary that's been provisioned is actually accurate. And when we say accurate, we mean accurate in two different ways. First, kind of contemporary, how recent is the boundary information? But the other is, as per our definition of accuracy, which is that we seek to represent individual countries as they would represent themselves. And so, considering the flashpoints around the world, considering somewhere like Ukraine and Russia, in our database, Ukraine and Russia may very well have overlapping claims. They may have overlaps in the shapefiles we provision because we ultimately are trying to represent both of those entities as, again, they would seek to represent themselves. The data set itself is actually quite large. And the reason for that is not because of the static layers, but because we retain the full lineage of every single data file. And so for any given, let's say you're looking at Russia's data files, you can look over time at every single file that has been submitted to the GeoBoundaries project, whether or not it's been rejected, if it has been accepted into the database, and kind of the pull request commentary associated with that. In order to build all of this data into something that is usable, we do use our on-premise HPC environment. Our full builds right now take around, I don't know, call it 6 hours or so to build every single file across the globe. And our final data product ends up being around, I think it's 60 gigabytes for just the single snapshot layers at the moment. We are constantly evolving. So right now we are, again, God willing, funded by the National Science Foundation. And so there's been a lot of improvements that we've been making to the database. We're just about to push GeoBoundaries 7.0, our seventh major release, which will be, I believe, our biggest release to date. We have around, I still have around 120 pull requests to formalize. And that's in addition to a lot of different kind of updates to our actual stack. So some of the cool stuff we've been doing is using LLMs to identify boundary changes, which this has been an undergraduate project that we've been working on that's just really fun. Some of my PhD students have been working on satellite-based metrics to improve our shoreline delineations. So right now, our shoreline delineations are not applied uniformly across the world. It's really based on the source we received. So we hope to standardize that. To date, we have been primarily based on bespoke technologies on our high-performance computing environment. With 7.0, we'll be moving into a fully containerized Kubernetes environment where if you wanted to stand up your own processing framework for GeoBoundaries, you would be able to do so. All of the documentation will probably be between 7.0 and 8.0 when that's actually more feasible, but the actual technical stack will have been fully shifted over into something that is highly containerized, which we are very excited about from a robustness state of view or point of view. The next big thing that we're working on is a new global and consistent ID system for all of our boundaries. Right now, our boundary IDs are based on hashing, and so they change. If there's a very minor change to a boundary, then the new ID that's generated is completely unique. This was based on our original philosophy that one geometry should always have one ID, and that if it changed at all, it should change dramatically. That was great, but it inhibited a lot of large big data analyses. If you want, you want to be able to see if a boundary changed from GeoBoundaries 6 to 7, let's say, and our old system really did kind of inhibit that. So we're working on a new ID system that will overcome that. The new ID system also, and we're very excited about this, it's based on geometry in a fairly flexible way. And what that means is it will allow us to release tables that will let you join information that you might have in, say, GATM or the United Nations data. Anything you have a geometry for, you'll be able to calculate kind of RID and join that data back into GeoBoundaries to try to provide like a universal gazetteer that'll allow linkages from almost any boundary data set. And then the last big thing we're working on, and this is something that the community has requested a lot, is providing guidance as to the hierarchical nesting of our administrative layers. So obviously ADM2 exists within ADM1, exists within ADM0. Counties are within states are within the country. We don't actually have metadata that describes those geometric relationships. So we're working on adding some metadata into our files that will actually allow users to reference what that nesting relationship looks like. What you'll see also, so we are trying to become more open to broader swaths of the community. Right now, in order to submit a new file to geoBoundaries, you have to know Git pretty well because you have to be able to do a pull request kind of in our setup. With 7.0 is also going to be becoming a nice little website that will automatically do that for you. So you'll submit your file on the website, all of the metadata associated with that file, and it will actually build a pull request for you and then automatically submit that pull request for consideration against the database. So this will allow anyone that just has GIS skills, but not necessarily GitHub skills, to begin to contribute to our repository. With that, thank you guys very much. And of course, as always, a huge thanks to all of our funders over the years who have made this possible. We were funded by the McGovern Foundation almost a decade ago, the Bill and Melinda Gates Foundation after that, and now the National Science Foundation has really been helpful for the next, hopefully, 3 years or so. So thank you guys very much. I'm very, very excited to answer any questions and chat about anything you would like.
Thanks, Dan. I don't know if you saw a glance in the background, but I just have so many big grins about all of your discussion, right? Like there's so many intersections to exactly what we've been building out in the last 10 years and shared experiences. It's just kind of almost, it's just crazy how much we can relate to what you're describing. And I mentioned in chat at the very beginning that you just did a wonderful job of describing the kind of complexity that goes on and tried to make like that simple map that we hung, like that we got on that globe that was kicking around, right? Like, why isn't that easy, right? And I think we constantly have this discussion with our users in TaxonWorks that is exactly because of what you just described, all those reasons. So it was really wonderful when they hear it from me and our developers, they're like, you're not doing it right? But when they hear it from you and they see that it really is a global challenge with many facets, hopefully there'll be some love shared all around in that regard. So I've got many questions. The chat is also blowing up with a lot of questions as well. I just want to start by pointing out that we need to go into some extra dimensions so we can talk for all morning, and we won't have the time for that. So maybe to cut right to the end, what's the best way for our community, and there's a lot of folks from global perspectives here, to participate in the like one-to-one connect with a human way with geoBoundaries? How do we connect with humans and make that connection? Because I think that's the biggest important take home in the long run.
Yeah. So there's really 3 different ways to get involved in the geoBoundaries project. The most common is users that have boundary layers that, for their little local country they're working in or whatever, that they know much better than we will, of course, and submitting those. That happens in lots of different ways. So on our website, you can submit boundaries. You'll be able to do it much easier come about a month from now when we have 7.0 go live. And then we very regularly end up in discussions with people that submit boundaries about why we can or cannot use that or changes that we might have. And we've learned a lot from those conversations. Inevitably, we learn about either constraints that our users are working under, or they will learn about constraints that we are working under. So that's one way to do it. The next is more generally, our GitHub is very, very active. So if you go to github.com/wmgeolab/geoboundaries, which is linked at geoboundaries.org, you'll see right now it's mostly our pull requests are very active because we're about to push a new big 7.0 product, but our issues are fairly active. Our discussions are fairly active. It's a good opportunity to engage with not just me, but the other individuals that make geoBoundaries go. We have an array of contributors from NGOs, from students at other organizations, from graduate students that are trying to solve their problems for their dissertations, that are all trying to work together to answer some of these problems. And so I would love to have your voices represented as we build further. Oh, sorry. And then the last way that people do engage, and this is much more rare, is on the code. So we have a separate repository. It's called our geoBoundary bot. And the geoBoundary bot is where we actually do the heavy lifting of how to build the data set itself, how to validate the data set, how to do a whole slew of different things in terms of just like reducing the precision of the data in responsible ways, calculating IDs, yada, yada, yada. If you are very technically inclined and love Python, the GeoBoundary bot repository is somewhere where you can also dig in a little bit. We, with 7.0, actually have almost completely finished refactoring that. And so that should become a much easier place to contribute to soon as well.
Thanks. Um, okay, so chat, I see all of your questions, and Santiago, thanks for raising your hand and repeating it in the chat. So I just want to say that I do see them. I do want to cover a couple of things that came up directly. So just as a little background, we essentially built a very similar resource. Let me step back one more level. We deal, Dan, with taxonomic concepts and taxonomic boundaries, and there's a nomenclature for all of those boundaries. And so we have a graph of related data that are species, right? And we're trying to figure out what those species represent. And so we have all of the same conceptual problems, many names for the same concept, right? Synonymous names, homonymous names, names and concepts changing over time, right? It is a completely parallel problem to what you experience. And what we did in Taxon Works is we know that taxonomists are incredibly detail oriented. They're incredibly systematic, right? They're taking and collecting all of the knowledge about a species and they're putting it in one place. And so one of those things is exactly where did that species live, right? We build distribution maps and we have lots of details and we need to combine exact point data, like we have GBIF representatives here who are aggregating billions of specimen points, right? And they're aggregating those. But there's also a long legacy of just as you described, the literature, right? The publications that says this species was found in this county. And so we're building a system that's recording that, and it needs to aggregate from that historical level all the way to that granularity, that point level. And that means that we needed multiple different approaches. And historically, how that's been done in these kind of databases, biodiversity informatics databases, is with text labels or with points. There's kind of a spectrum there. But we built it out from a spatial perspective for many of the reasons that you described. And what we did is we started with 7 different gazetteers that represented, 5, I think, different gazetteers that represented the kinds of things that were being referenced. For example, TADWIG, the Taxonomic Databases Working Group, put together spatial representations that weren't geopolitical in nature, but some were, but some weren't. Yep. And people started referencing that data in the literature. So we need that as
we were at one point working with KBIs because KBI somehow overlapped with ADMs in some odd ways.
Yeah,
fascinating. Yeah.
Right. So we had TADWIG's data. We had natural earth data for representation levels. We brought in all of GADM, right? We brought in ISO standards. We brought in, what were some of the other ones? There's 2 more that are escaping my mind. And so then we had to figure out how to merge those all into what we call geographic areas. And then, as you alluded to, not all of them shared the political metadata, so that we couldn't say this parent-child. And so sometimes in our data, people are like, well, I picked the country, or I picked the state or the province or the county, why isn't it showing me the country? Well, because those disparate data sources didn't have that metadata. So I think that's just to go to say that we didn't want to have our taxonomists, at least this was the philosophy, have to curate another world that was equally as complicated as curating what species concepts and what their nomenclature was, right? Like, we need to have this parallel level of curation. And what you're doing, I think, in geoBoundaries gives me great hope that our communities can jump back and forth, curate their spatial observations in geoBoundaries. Ultimately, we work towards that, and curate their taxon concepts in something like Taxon Works. If you go look at our issue tracker, there's 60 or 70 geospatial things that are exactly the kind of things that I see in your issue tracker, in the old GADM issue trackers, and like they're exactly the same. You know, areas in conflict, this kind of thing. This isn't right. This is missing.
Just briefly, I'll say too here. I've had the same conversation with 2 or 3 different communities now. I was just last week talking to the population demography community. And it was the exact same storyline. IPUMS, one of the largest groups there, has their own internal database that they've curated, and they said the exact same thing. They got 7 different gazetteers, and they don't. no one wants to do that. Like you just want the map on the wall. And it's really unfortunate. I think my community just hadn't done that. And so I'm really excited kind of some of the bridges that we can help to build across lots of
Yeah,
different.
yeah. Okay, let's get. I have a couple of questions I really want to get to, but I want to get to chat's questions. Santiago, I'll go in reverse order. I know there's some above guys. Um, Santiago asks, you talked about shorelines. One important lack of standardization is islands. Any progress on these?
Yeah, so we have a basically right now we have a pretty small algorithm that we're running against Sentinel data for island dominated and all shorelines, but we're treating islands the same as that. That Sentinel based algorithm is looking pretty good right now, but we aren't ready to just click go. We want to get to, kind of one more round of curation against it. I suspect that will get released in 8.0, so we're probably looking to the next big release, but it'll be sometime over the next year where it actually goes live. Just so everyone on the call is aware, the numeric releases for geoBoundaries are a bit arbitrary. They're really there for replication purposes. We update regularly with just GitHub hashes, right? I mean, we'll push a new version, it'll
Mhm.
become a GitHub release, but we don't formally call it 7.0 or 8.0, but about once every year or 2 years, just so that people can cite a specific release when they're writing a
Yeah,
paper.
yeah. All right. Gail asks, do you maintain ADMs that and I think you touched on this, that can reflect historical boundaries by year and span? Thinking of coding legacy data, how accessible can such data be? So I think the idea is that we want to capture what the paper asserted, and that's not necessarily what present asserts, right?
So we are with the current release moving into a world where we could do that technically. Right now we couldn't. Right now we are representing kind of the contemporary time. The change we're making is the back end of GeoBoundaries is moving into a much, I'll call it a better, just simply a better database that actually is retaining what we are calling periods of validity. So these are the known periods of validity for each layer that is going into the GeoBoundaries product, and then we're going to keep those forevermore. So going forward, we will start to be able to build out time series and having people even potentially submit historic boundaries so that we can start to build out what these time series look like. That said, right now, I would not even begin to pretend our data set can do that. Our data set is still trying to grapple with just the modern world, and we haven't really started to go back in time. There is one group, it starts with that. I want to call it like GLED, GLED. If you email me, please email me, Dan. I'll put my email in the chat. I can send it to you. There is a political science group that worked really hard to do that. I think down to ADM1, but I don't know if it's still maintained or not.
Would be wonderful to know. Um, so Tommy asks, how are you dealing with climate change, changing shoreline data?
So this is why we want to do it with Sentinel, is so that when we push new releases, we can actually base what we are calling shoreline on something that is observable. Right now, it's based on the source. So, like for
Mhm.
example, if Ukraine releases, Ukraine's a bad example. Let me pick something less controversial. I almost said Cuba. Panama releases a release of kind of these are our territories. We just accept that as truth. So if they draw their line on the shore, we say, great, that sounds good. We're taking it. However, what we're seeing more and more is like many of these contiguous land territories that are being claimed are now water, or they don't exist on these edges. So what we'll be doing in the future is snapping essentially to a sentinel detected shoreline in pretty much every single case.
So can you say a little bit more for people who don't understand what that is? A sentinel detected shoreline.
Oh,
What
sorry, yeah.
sentinel? Yeah.
Yeah. My apologies. So the European Space Agency has a satellite called Sentinel. It's currently Sentinel-2 up there. Sentinel is a multispectral sensor, so it does RGB, red, green, blue, things you can see, but then it also has near infrared, shortwave infrared, and even some radar bands. That information, that satellite data, it's about 10-meter resolution, give or take, depending on what band you're looking at, sometimes finer, sometimes coarser. That can be used to detect for the globe where shorelines are. And so that gives us to a, within 10-meter level of accuracy where shorelines are. We hope to use that to basically snap and refine our existing boundaries so that we can get a more kind of global systematic view of shorelines. One big problem we have is that some countries will release boundary information that includes their exclusive economic zones out in the water. And in those cases, we have to make kind of manual decisions about where we are calling actual contiguous land. And then we,
Hmm.
we, we literally will delete the areas that are in the ocean. We don't want to be in that business. We want to have one kind of deterministic way to do that.
Uh-huh. Fritz asks, can you explain a bit more, can you explain more how the contribution from GitHub works? For example, I saw countries in like Dominican Republic that is marked as data from OSM, but now I see that government institutions share boundary files. Is that something I can point to for you, or how does that work?
So the easiest way is to just create an issue. And in that issue, basically tell us that exactly. Send us the link, and then we can have a discussion about if that is a better file that we could use. Um, the harder way to do it is to actually download that data and kind of do a little pre-processing for us, and then submit that kind of data through our pull request system. I'll share something actually with you here real briefly. I think I'm sharing my screen now.
Yep.
Yeah, geoboundaries org/. Sorry, I'm not on my usual computer here, so oh, I remembered the URL. Here we go. So the other way to do this is this. So this is not that publicly accessible right now, but this is what we will be announcing in about a month's time with GeoBoundaries 7.0. So geoboundaries.org/gb contribute. And this is what we expect most people will use to contribute to GeoBoundaries in the future. This is a very straightforward process where you drag and drop your shapefile, you input all of the different metadata that we need in terms of the shapefile itself, and then you can just submit this to us, and that will automatically generate a pull request in the format we need to then assess it further. And so this is probably the optimal way. It's a little janky right now is the only concern. Like there's a few bugs in this, which is why it's not public yet. But this is probably the easiest way to do it.
What level of resolution are you looking for? If somebody submits and does some work or has found a set of geospatial shapes, what level of resolution is valuable? So, maybe you don't want polygons of 100-kilometer resolution. Is there any kind of guidance on that regard about what we should be looking for?
So it depends a lot on the level of the administrative boundary. And the complexity. So as an example, Russia's ADM0 is actually high resolution because of the nature of their northern boundary. And so the northern boundary of Russia has many, many, many different inlets and fords and things like that simply need a high level of resolution to accurately capture. Conversely, many African nations, you can almost draw their ADM0 with 4 points. It was
Yeah.
defined by Great Britain when they left. And so, it's really driven very heavily context dependent. In addition, as you go down deeper, so if you're talking about ADM2, like counties, those generally have more precision than your ADM1s, than your ADM0s.
Okay.
We do have a tool on the website. I should just keep sharing my screen here. Here, hold on, I'll share again. So we do have a tool on the website. If you go to, let's see, my individual country files and visualize data. There we go. So this is our contrast and compare tool. This is kind of us showing people why it matters where you pick boundaries from. But one thing we do is, so this is comparing a data set from Esri that they released to our open data set. And we don't try to make comments about right or wrong necessarily. We just try to help people understand the differences. And so just as an example here, these two are the vertex density of the geoboundaries data set. We have one vertex about every 105.6 meters. The Esri has one about 237.7 meters to represent this area in Nicaragua. And you can see, right, that causes differences. Yeah. So in red, right, you can see Esri has lower precision. And depending on what you want to do, that might be fine. If you're just creating a map for visual purposes, then Esri's lower resolution product might be just fine. If you need a higher level of granularity for species distribution, then
yeah, right. So thanks for this tool. We use it. We've regularly been using it now. And you brought out that exact point. Guess where people collect insects? right along the borders, and right along the borders that are rivers. And so when you have one, it's across the river on either side, and your geospatial boundary is in two different states, people get really upset, right? Like they're like, no, I collected it here, and my point is perfect. Why can't it show up in your state? This happens all the time for us. And that's completely why you described right here, is because the geopolitical shape behind it is just doesn't have that level of resolution. But it's a classic problem for us. Yeah. Yeah. Yuta asks basically about and you touched on, you alluded to sort of this, the you alluded to some stress, I would say, maybe on this front, but can you say what your long-term funding is? Often one of the questions that we get when people come to us, especially at this little Taxon Works Together, or when they think about adopting the software, is they ask, are you going to be around in 3 years? And we're an endowed project, so we have some nice stability in that sense. But come to our business meeting, and you'll also hear about some stress that's going on right now. So, what about your support and your long-term planning? And I would also ask you, from sort of like a sister organization in some weird way, how are you thinking about making it stable over the long period of time?
Yeah, so because GeoBoundaries was born out of a world in which nothing was sustainable, we kind
Yeah,
of took
yeah.
sustainability as our guiding star, to the point where we can scale with funding that ranges from about $5,000 a year up to $5 million a year. We've never had 5 million. We've had like 500 one year, but
Hmm.
it's really designed to where we can survive no matter what, because we're so community centric. So many of our boundaries come from community submissions. We also get a tremendous amount of baseline support from William and Mary. So William
Uh-huh.
and Mary, all of our compute is provided for free. All of our hosting and egress is provided for free by Microsoft as well. So we have
Uh-huh.
we have really, and even if Microsoft were to change its mind,
Hmm.
William and Mary would actually backstop us, and so
Uh-huh.
then still be able to provide egress for free. So we're really fortunate to be in that situation. The only cost that we really have to worry about is undergraduates to help to process the data, right? When we need to
Yeah.
fix errors and things like that. So that really helps a lot. The downside to that is we move a little slower than we would like. Like if you submit a boundary today, it's probably going to be August until it gets processed, because that's when the undergraduates come back to town. That said, right now we do have very secure funding and ample funding. So we are currently funded by the National Science Foundation. We have a 5-year award from the National Science Foundation out of the Human Networks and Data Science group. We also have some really, really good foundation partners that have come to support GeoBoundaries numerous times over the years in numerous different ways. We are fortunate in many ways in that we have such a broad user base across so many different communities that it makes us,
Hmm.
I think, a little bit more resilient
Hmm.
than we might otherwise be. So two different answers to that, right? Three, right? Diversification of our user base, really low potential for operating costs, and then the National Science Foundation has very long-term support for us right now.
Thanks. So let's talk a little bit more about people and I'm curious about this. A lot of what software is now actually social. It's about creating that community. It's about training new users. It's about getting that community to help and grow. Teach other users, get them familiar with the tools, etc. Are there kind of social structures that you have in place? Do you have, for example, like a carpentry style lesson that says, "Hey, learn how to contribute to GeoBoundaries," or how do you teach your undergrads? How do you find that community maintainer that is just triaging GitHub issues? How could somebody here in this community bootstrap their knowledge so that they could maybe help triage issues or gain your trust? That know, love, and trust relationship.
Yeah, so this is actually the next year of our NSF award is this verbatim. It is taking the tools and techniques that we use to train contributors and making them, one, up to date, but two, publicly available. Right now, those are kind of in bespoke internal training sessions. We held workshops pretty regularly for GeoBoundaries for our user community. If you're on our listserv, you'll see those come out about once or twice a year, where we get people together and we kind of just teach them how that process looks. But we want to stop doing that. That's actually a very expensive way for us to do this, and we can only do it once or twice. So we'll be creating a series of kind of online YouTube style opportunities for people to just learn what these processes are, how to use the data, how to process the data, and hopefully how to get more involved in the community.
All
We
right.
also are going to have a new set of documentation coming for 7.0, because our documentation is terrible, and we've finally gotten around to improving it.
Debbie, you have your hand up.
Yeah, so thank you for asking that question, Matt. I want to re-emphasize. So I and many others are in this room today have been part of and are part of things like creating workshops, for example. And when you have the sustainability conversation, you hit that exact point very quickly. How often are we going to do this? We only hit a certain number of people. You have to repeat it. People come and go out of the community. So folks like the carpentries, you might be familiar with data carpentry and software carpentry. Yes, Dan? So creating resources that are online, creating resources that people can update and contribute to openly, that are versioned, and making that so that it's open to all, is certainly a really important part of this conversation. So that there aren't these boundaries to I got invited to the workshop or it's not till next year or yeah. So definitely glad to hear that strategy.
Yeah. Dan, I want to ask you a little bit of a technical question in here. So, in looking over GeoBoundaries, and we are seriously thinking about adopting it, and maybe in the chat, folks would be, maybe if you're a TaxonWorks user in chat, how would you feel if we auto translated all of, I think there's something like, there's well over 500,000 asserted, we call them asserted distributions, this taxon in this shape according to this source. How would you feel if we translated all of the asserted distributions spatially into something like GeoBoundaries? Just in the background in the chat, +1 if it's a good, just put good idea in the background. But while I'm doing that, Dan, one of the things that we were thinking about gets back to that identifiers and get back to thinking about how we're going to synchronize our data when you make new releases. So from my OWL web ontology language, building out ontologies, we did a lot of, there's a core concept that says that you never delete data, you just deprecate it and you point it to that new system. But that process of deprecation and linking the old to the new adds another curatorial level, right? Like now you're committed to maintaining a set of metadata to say, hey, if you choose this state and you should now choose this state, right? So it lets users reference the old, but then kind of migrate to the new. So can you say a little bit more about your identifier scheme? And it can be technical at this level. There's some technical folks here. And how you're thinking about managing deprecation from version to version?
Sure. So this is actually something we're really excited about. I wish I was at home and I could show you a little PowerPoint slide on this, but I'll have to do my best to describe without it here. So within the geographic boundary community, IDs have been largely arbitrary. They are alphabetical order. They are whatever GADM decided they were. It's just people just created boundaries. When we first created geoBoundaries, we said that's a bad idea. Boundary IDs should be linked to the boundary. They should be in some, you should be able to take the geometry and recreate the boundary ID if all you have is the geometry. So we did that. That was our original take. We hashed the geometry and that's how we got our ID. Now that strategy had the big problem of that means anytime the geometry changes even a little tiny bit, that means your entire ID changes. And that's really deleterious for people, that the exact problem you just said, right? Like you don't want to have to push updates every time you move one vertex 1 meter. So what we are going to be implementing is a universal ID system that's still based on the geometry, but we think in a fairly novel way. So if you're familiar with Web Mercator, you're probably not. Web Mercator is a very specific type of projection. And Web Mercator effectively has an indexing system that is global across the entire world that has two pieces of it. It has a latitude and longitude corner, like upper left-hand corner, and a zoom level. And so what this is used for is like on Google Maps. When you go to Google Maps and you zoom into a spot, it will figure out what zoom level you're at and what your upper left-hand corner is. And then it can load the appropriate satellite imagery to show you when you're zooming and browsing around. So what we're going to be doing is we're going to be taking for every single one of these geometries, we'll find the bounding box, the smallest bounding box it could fit in, find the Web Mercator tile that it belongs to at the coarsest zoom level we can, and then we're going to be superimposing a grid across that boundary. And that grid will be represented by a series of zeros or ones, which is does the boundary intersect with that grid cell or not? And so that will give us, for every single geometry in the world, a unique geometry. But if the vertices move just a little bit in a way that would just move them from one place in a grid cell to another, you'll still have the same ID.
Yeah.
So that's where we're moving towards. And the cool thing about that is we can use that to construct an ID for all of GADM. for
Yep.
all of Gaul, right? So then we can actually join all of these together using this kind of universal ID system.
So can you say why you chose that? So we're thinking of exactly the same thing and implementing the exactly the same thing, but using Uber's H3, I think it is.
H3. So we
Yeah.
considered that. Yeah.
Yeah.
We actually we had a
So
whole
why not? What were the, can you summarize the key points?
Yeah, so H3 is great and definitely a reasonable solution to that problem. The reason we opted to use Mercator instead of H3 is H3 has some oddities about it that make it
Hmm.
a little complicated. So you may not know, but in H3 there's like six there's what is it, six pentagons. Everything
Hmm.
else is a hexagon, but there's like six
Right,
pentagons.
right, right.
Just like there's enough weird stuff about H3 to where we just decided it would be simpler, right? I mean, just choosing the simplest solution to use the web Mercator system as opposed to the H3
Yeah.
system. H3 though, I think is a perfectly valid approach to that as well.
So mostly that was just you feel confident that the web Mercator indexing is going to meet your needs essentially. There's not going to be this. I guess the question is how lossy is going from web Mercator to H3 or H3 to web Mercator, right? Like that's really
Yeah.
what we're getting at. Yeah.
Yeah, and I don't think at the end of the day it comes down to how much you like hexagons versus squares, right? And there are
Yeah.
trade-offs there. I mean, I used to work in the climate science community, and like there are differences if you represent things as hexagons as opposed to squares. For us, we are not doing flow modeling, right? I'm trying to construct an ID. If I was doing flow modeling, then I would probably be using H3, despite the fact it has a little bit of additional complexity.
Uh-huh.
But lacking kind of like a reason to go to that more complex data layer. I actually started with H3 and my PhD students convinced me I shouldn't do it.
Oh wow.
Because
Wow.
and the argument that won the day was simply the complexity, the added complexity of doing this was H3, which there
Yeah.
is considerable added complexity. It is very, with Mercator, you can solve the four corners of a square trivially. The
Yeah.
math to solve your 6 points in a hexagon is much less trivial. Um, that added complexity didn't give benefits for our
Yep.
particular use case.
Yep. So I
That's not
think
to say it wouldn't for yours, but it
yeah,
was
no. So this is, and I guess I don't know because, and I would love to hear from people who are working at the population level, maybe even at the GBIF level, but actually doing that scientific compute for biodiversity where it may or may not, matter. And I think that's what we want to hear. But it's been absolutely fantastic to hear you spell out those reasons for those two different things, because I think we will at some level adopt some gridding for, the kind of mapping that we do. We do a lot of aggregation and we do the compute to build so that aggregation so that we can share out some of the maps at the GIS level. I could show those, but we're kind of quickly coming up on time. But there was a great question from one of our resident geospatial and standards leaders. John asks, does geoBoundaries maintain synonyms of names of boundaries?
we do when we have them. So
Uh-huh.
that's not universal within the database right now. If we have alternate names, we do maintain those alternate names. We do that in
Mhm.
two different ways. We do it within the name fields themselves. So sometimes we'll have a name field and then kind of an alternate name field. Um, that's rare. Where we more commonly do keep that is in retaining the canonical name of the boundary itself.
Mhm.
So as an example, in the United States, we call it a county, right? In France, we call it a district at the ADM too. So trying
Yeah,
to
I
retain
see.
those types of things.
Yeah.
We do retain those kind of synonyms as well.
Okay, in the interest of time, I think we're going to wrap this up. Dan, I think you should pencil in joining our conference next year at this very time. There's so much we want to follow up on with our community. I would love to do a show and tell that talks about possible connections if we can move things forward. As you alluded to, these things take a lot of time and they're dependent on our community resources. But I hope we continue this conversation and I hope we can do it again. It was really exciting for us, and I think the chat enjoyed it as well. So, any other things to wrap up? Debbie, you wanted to jump in?
Sure. I just want to say we have just another minute, and I want to continue that maybe we have another conversation with Dan before that with the group, for example, with your students
Mhm.
that you mentioned, Dan.
Yeah, it'd be fun.
So helping us all understand that we're all doing this and running into the same issues. So Tim Robertson also added another one about GBIF uses non-marketer for the polar regions.
Uh,
John is reaching out and said he wants to understand the process. I assume he's referring to the synonyms. Um, And should he make a GitHub issue? Or John, can you explain what you meant there really quick?
Dan answered that. Issues would be great.
Okay.
Exactly how to produce those issues, what they should look like is a story to be told
Well,
still.
what I could do is I could say, hey, undergraduate, go look at that issue. So that, and then we can kind of build from there, I think.
Fair enough.
Yeah.
Okay. In the interest of time and giving our next guest time to
moment.
set up a moment. Thanks again, Dan. We're very grateful for your time, and it's great. It's been overdue. We should have made this connection several years ago, but I'm glad we're making it now, and I look forward to working with you guys and seeing geoBoundaries evolve. Thanks so much.
Thank you guys so much. This was a lot of fun, and I love meeting the community.
Thank you. We really
All
appreciate it.
right.